Hello, physical science. It's time to talk about the periodic table. The periodic table is a culmination of trying to organize and understand nature, and one specific part of it is the elements that things are made of. The early alchemists kind of grouped things together. The ancient Greeks grouped things according to fire, water, air, and earth. In the 1800s, there was a Russian guy by the name of Mendeleev, and he noticed when you grouped things by mass, everything there were repeating patterns of 8. And from these patterns, he was actually able to predict some elements that had not been discovered before. He predicted their rough mass, their rough density, even the color and behavior of missing elements. And we found them. So the first one discovered, he called ecosilicon, and the official name actually became germanium. So that was the first element that was ever predicted, and it was from an early periodic table. Now, an English guy came along by the name of Moseley and realized, oh, if we group the periodic table according to atomic number, it makes a whole lot more sense. And that's what we use today. So the periodic law, if you will, is basically what Mendeleev discovered is when you put them together in certain ways, you get repeating patterns. And the way that we put it together now is by increasing atomic number. And if you remember, atomic number is the number of protons. Okay? So you need to know that the periodic table is grouped by atomic number. We go left to right, top to bottom, and it increases and increases. When we're talking about the parts of a periodic table, there are two main things. These are the directions. When I tell you to go find an element, I will say it's in period 1 or period 2. These are the horizontal rows on the periodic table. Now, the other thing are called groups, and to remember which one is which, I've got a little memory trick here for you. What happens, okay, it doesn't do it on your phone, that's what you're used to, but on a computer, what happens when you hold down the period key? You get periods going from left to right across your screen. The horizontal rows, these things are the periods on a periodic table. So just like holding the period key down, they go left to right. Opposite of that, we have the groups, which go down. Another name for them is families. Sorry, I could not remember that, even though it's staring me in the face. And when I taught at Milton, the school over there that has these columns in the front of it, it was real easy to get them to remember those were called groups or families. Because I told them, picture the columns standing around in a group or a family, and that's, the vertical. So I guess you could picture a family all standing up, walking around, or grouped together. So the vertical columns, those are called the groups. Those are the up and down. Now what's interesting is when you look at the structure of the electrons, not each electron, but how they're organized within each element, everything in the same group has the same basic configuration. This is called an electron configuration, which means they all have the same, I almost said same, very, very similar properties. So we'll get to some of that. When you are looking at a periodic table, you're going to have the atomic number, which is our number of protons. We're going to have the symbol, which is always an uppercase letter. If there's another letter, it's going to be lowercase. For instance, there's an element called cobalt. CO. If I wrote capital C, capital O, that's two elements, carbon and oxygen. That's a poisonous gas, carbon monoxide. Cobalt is just a metallic metal. There's nothing really to it. So very important that you follow that nomenclature. And then we have the element name. Below that, usually at the bottom, is the atomic mass. This is always the decimal number because it's an average of the natural isotopes of that element. We talked about that last week. Some atomic masses are whole numbers in brackets. That means that that element is so unstable that they really can't say which, there's no average to it. It's synthetic. We make it in the lab. Sometimes they can last a thousandth of a second. Sometimes they can last a minute, something like that. But typically it's a decimal. And if it's weird like that, it's going to be in brackets. So here's an example of what you see on the periodic table. Your atomic number up at the top here, your chemical symbol, and then not all periodic tables have the name, but it's nice when they have it, and then our average atomic mass. Okay. There is a thing called an atomic mass unit. When you look at that, you're like, that's so weird. No, it's like pounds or grams. It's the unit of mass of an atom. An atom is like a billionth of a billionth of a billionth of a gram. That may be too small or too big, the phrasing I just used. So we actually use in what are called AMUs, or atomic mass unit. The definition is that it is 1/12 the mass of a carbon-12 atom. A carbon-12 atom means that the mass is 12. If you look at the periodic table, carbon is atomic number 6, so it has 6 neutrons. So essentially an AMU is the mass of a proton or a neutron. Okay? When we're talking about the elements, the Greeks like to say fire, earth, wind, water. Well, in general, we've kind of got these things. Our elements, as found on Earth, are going to be solids, liquids, or gases. There are other phases. Y'all are probably familiar with plasma, which is actually in the very center of the fluorescent light bulbs or the sun. And yes, the temperature inside the fluorescent light bulbs is as hot as the surface of the sun. It's just such a small area that there's very little heat, but there's a good bit of light. There are other phases. We're not going to get into those, though. They're crazy. They're weird. They're cool, but we're not going to get into those. Classes of elements, we like to say that they occur naturally or not naturally. The alchemists were the ones trying to turn base metals into gold, trying to turn elements from one to the other. And we can do that today. It's just cheaper to go through 1,000 tons of ore to get a few grams of gold and then deal with the environmental impacts than it is to actually make gold. So possible, expensive. Another good group of classifications is metals, nonmetals, or metalloids. Metalloids is kind of a weird name. Back when I grew up, a long time ago, we called them semi-metals. So metalloid is basically in between metals and nonmetals. They're a little weird. This is what are used in computer chips. So on the periodic table, we have the metals. These are the left side of the periodic table except hydrogen. Hydrogen is way over here. There's a reason, but it's all lonesome. And you'll notice when I say left, it's kind of a slanted line here. And I'll tell you what that line is called. So everything here and those 2 rows at the bottom, what are the rows called? Periods. Good. These are the metals. A metal is a good conductor of heat and electricity. This is just a generic term for all the metals. Some are better than others. Gold is one of the best. Almost all of them are solid at room temperature. Which metal is a liquid at room temperature? Mercury. Next we have a group of metals, but they're a little special, so they're called the transition metals. The transition metals are in what are called groups 3 through 13. So these right here, In other words, and I'm using a phrase I hadn't before. This is group 1, group 2, 3, I said 13, through 12. Sorry, that's 13, and it goes to 18. So the little section in the exact middle and the 2 rows down here are called transition metals. Those 2 rows are called the lanthanide and actinide series. Series, here we'll do that right now. Series is the old term for period. And now that I'm saying this, I'm getting a memory here. That's what we called them in high school. We called them series. But the name for lanthanide stuck. So this one is the lanthanides, and this one is the actinides. If you're trying to memorize that, just think, Los Angeles or something like that. LA. That's how I always remember the actinide series. To come up with your own which ones are the lanthanide and which ones are the actinide. So come up with your own, but that's what I used. We have the nonmetals, which are everything to the right of the periodic table, and also hydrogen over here. So those are all nonmetals. They are poor conductors of heat and electric current. Okay, I told you hydrogen's weird. It actually, on Earth, it's a nonmetal. But Jupiter, most of the hydrogen is compressed in the center, and it is so compressed it starts to behave like a liquid. And when it behaves like a liquid, it's like an extreme metal. The magnetic field produced by that hydrogen on Jupiter can be picked up with an AM radio here on Earth that makes these weird noises. If you can, be out away from civilization without radio waves, you can actually hear Jupiter on your car stereo. But that's a very extreme case, and when I say that, then you go, oh, that's why it's over here with the metals, because it's just a weird element, and it's most of the universe too. It's kind of neat. Most of these are gases at room temperature. If they're a solid like carbon, I went too far. If they're a solid like carbon, they're going to be brittle. So if you think of like charcoal is, from the grill. That's carbon, and it's brittle and, chalky. Now you're going, ooh, chalk. No, that's not an element, that's a compound. Diamond is also carbon, and you go, but that's not brittle. Well, if you can smash it, it'll break in little pieces. Just don't do that. I don't know how much force it would take, but I don't think a hammer would do it. And then we have the metalloids, which are this weird little diagonal that I was talking about. These are between the metals and nonmetals. They are, on a lot of periodic tables, there's what everybody calls the stair step. So you will see this bold-faced line that makes a stair step. So those are the metalloids. They have properties of metals and nonmetals. That's the cool thing about computers, is at a certain amount of energy, they behave like a metal, but if you drop the energy, they behave like a nonmetal. So they go back and forth. Those are called semiconductors. They conduct electricity sometimes and sometimes not. Those are your microscopic switches that a computer will do. So in general, your periodic table, if we're talking about metals, nonmetals, and metalloids, we group them like this. Those are the metals. The metalloids are in between, and the nonmetals are way to the right. The only weird one there is hydrogen. And I did say that hydrogen can act as a metal in places like Jupiter. That's so bizarre. You need such extreme pressure and temperature. They couldn't achieve that until like 20 years ago in a laboratory on Earth. They couldn't achieve that. So it was all hypothetical, and then they were actually able to do extreme pressure and temperature in a small space, and the hydrogen acted just like a metal as they predicted. So that told them a lot about Jupiter. But all you need to know, non-metal, it's gas at room temperature and so on, because we're not going to Jupiter anytime soon. Okay. So the groups in a periodic table, these are the vertical columns, also known as families. Each one, for the most part, has a name because they have really cool properties. Or, I'm sorry, very similar properties. Yeah, some are cool. I'll tell you about that. First thing you need to know is what is called a valence electron. A valence electron are electrons in the outermost energy level. We would say the outer ring or the highest energy level. So every group on the periodic table has the same number of valence electrons. It's the outermost electrons that we're talking about here that will interact with other elements. That's why they all have the same properties. Okay, for instance here, the red dots are what are called the valence electrons, the outer shell. So if you look in group 1, all of those have one valence electron. These have 2. These are weird. These have 3. These have 4, 5, 6, 7, and 8. And you'll notice helium only has 2 electrons. It's not over here. It is in this group for a reason. We'll get into some of that. You'll learn a lot more about that in chemistry next year too. Okay, the first group has a name. They are called the alkali metals. That's group 1. They have a single valence electron, just as we talked about. So if you write one of the alkali metals, sodium is Na, you would put a dot next to it representing that one valence electron. They're extremely reactive. Like I said, there's some really cool ones. They're so reactive you will never ever trip on a chunk of sodium walking along unless you got serious problems here. They're always found in compounds. All right, let me put this up for you. It's a good one. So this is lithium, dropped in some water, and it releases hydrogen gas, so they brought a match up to it, and it's burning on top of water. It's kind of neat. Sodium, I was a little too fast, this is not my video. You drop sodium in water, and it's reacting. And I've never had to light it with a match. It can light itself on fire. It's so reactive. And then it exploded. Potassium, I've never done this. They dropped it in the water and it exploded. So little tiny firecrackers. No heat or anything. It's just doing it on its own. Rubidium. So we're going down group 1 on the periodic table. Yeah. Cesium. Oh yeah, we got to see that again because, cesium. I mean, isn't that great? I have never seen a display of cesium in water without the container being destroyed, except for the video where they did it in an old-fashioned cast iron bathtub, and they put enough in there that they destroyed. I mean, the curtains went flying and everything. I think there was broken, the mirror in the bathroom broke, and it was cool. I don't know where I found that video. You could probably look up cesium on YouTube and find some more. Okay, the second one are called alkaline earth metals, group 2A. Now, if the first group, those are called alkali metals, you're going to want to remember how to tell which one is which. Something that I did back in high school and I still do today, alkali metals has 2 words. Alkaline earth metals has 3 words. The first group has less words, the second group has more words. However you want to remember that is good. These have 2 valence electrons. So I would end up writing one of those as magnesium, and I would put 2 valence electrons around it. What you do is you kind of fill it up around the element symbol as you go here. Okay, other common families. This is one that I was mentioning, groups 3 through 6. Now you're going to see like 1A, 3A, and all that. Don't worry so much about that. Just think of the numbers. These are named after the highest element in the group. So the first group or family is called boron, and that has 3 valence electrons. Then we have the carbon group, the nitrogen group, and the oxygen group. Those are boring names because, well, you better not get any of those wrong, because you'll have a periodic table and I'll ask you what's in the carbon group and you're going to say silicon, and you better not say oxygen. So that's pretty easy. The next group have their own special name because they're kind of neat. They're called the halogens. These have 7 valence electrons. So we've got 7 electrons around the symbol here. And they are different, but they've got some good chemical properties. They're highly reactive. This one right here is chlorine. Chlorine gas was the war gas used in World War I. It irritates the lungs, and it's heavier than oxygen. It's more dense. So during World War I, when they fought in the trenches, the enemy would launch chlorine gas, which would then displace the oxygen in the trench, leaving you with nothing to breathe. And now your nose and eyes and mouth, all your, the mucous membranes, are severely irritated, and your lungs can produce enough fluid to counter that you end up drowning. You never thought science would be so gross, did you? You took biology. So these are definitely reactive. And as far as the chlorine, here's a little safety tip for home. I'm going to tell you how to make it because you need to know, because it's so darn dangerous. My first job was at Chick-fil-A, and there's this guy named Danny. Everybody knows Danny, okay? He decided that he was going to super clean the basement and put every single chemical in the mop bucket. Those of us downstairs on break and the manager in the office suddenly started coughing and retching, and everybody ran upstairs. And Danny was the one closest to the mop bucket, so he ended up sitting. We probably should have called an ambulance, poor Danny, but he was hacking up a lung there for like an hour. And I'm not laughing at Danny. You would too. And what he did is he made chlorine gas. If you add bleach to ammonia, so something like Windex and bleach, you're going to make the chlorine gas. So if you read your containers, your cleaning products, they will specifically say do not mix with bleach or other things because, well, you make chlorine gas. Now, I know that half of you are going, awesome, and you're going to hunt for it now. Don't pause yet. I'll tell you how to do it safely. You can take some bleach and some Windex, something like that. Go outside. Do not do this indoors. Don't even turn on the bathroom fan and do this because, like I said, it's heavier than oxygen. You need enough air to push it up off the ground and get it out of there quick. Do not do it in an enclosed space. Do it outdoors. Pour a little bit on the driveway, and really not much. Pour a little of the other on the driveway, and you get this white smoke coming from it. That's the chlorine gas. And you don't really want to inhale that. Yeah, it'll kind of remind you of the pool smell, but this is the concentrated stuff, and you don't want to be inhaling that. So the reason, keep in mind, the reason I told you that is because I don't want you doing that in a bathroom enclosed space. You start coughing up, and then you do something like sit down on the floor where there's an even higher concentration, and you end up passing out, and people do die this way. I don't think it's as common with the bleach, with the household cleaners and stuff that people do that, but could send you to the hospital or something. So definitely want to be safe with that one. And to be safe, definitely in a ventilated area outdoors is best. Okay, the last group here are called the noble gases. They are group A. They don't have any color, they don't smell, they are extremely unreactive. If you've ever breathed in helium from a balloon, you're probably going, well, I don't know, it's got a smell to it. No, that was the balloon. That's like the powdery stuff in the balloon that you're inhaling. It's kind of nasty. But helium is a noble gas, and just so that you know, it's kind of cool. The speed of sound through pure helium is much faster. So when you inhale it and talk, okay, biology people, the thing in the back of your throat that your voice box, whatever it's called, it vibrates at a little different speed, which is what changes your pitch. Another noble gas is xenon. So if you look at your periodic table, that's way down at the bottom, and it's got a very, very dense, it's a very heavy one, so it's a very dense stuff, dense gas, and I've not dealt with it in person. Actually, it might have been below xenon. I don't remember what's at the very bottom there, but I saw a video. I've never seen this in person. I saw a video where a guy is filling up balloons with noble gases, and he fills up helium and it flies away. That's great. And then neon, and it kind of does that. It just kind of hangs around, but the rest of them just fall. And with xenon, remember, he's sitting up on this wall. He drops the balloon, and it drops like a rock, and you hear it splat on the ground outside of the camera view. If you inhale xenon, you gotta do it carefully because it can sit in your lungs and you don't have any oxygen to breathe. So I think you probably want to do it with like medical expertise available so that they could pump it out, pump that oxygen in. But I want to say it was on Mythbusters or something where they breathed a little bit in and then they talk. And their voice is really, really deep. I mean, I can't even do it. It's like ridiculously deep. It sounds like a horror movie that Hollywood put together or something. It's kind of neat. So, and I said that as far as the valence electrons, these have 8 valence electrons around them. Technically, it's a full outer energy level, and helium fills up at 2. So because it's full, that's where helium is, right up there. And it does fit along with those other gases. Makes perfect sense. So here's a standard periodic table. We generally don't give them out, bright colors like this and everything. I'm going to get a periodic table. I'll probably get it from webelements.com. They've got some really nice printable ones, and upload some periodic tables for you to use on your homework, tests, etc. And that's it as far as the modern periodic table. Have a good day.